10 real senior backend questions. Most engineers miss half. How many can you answer? Question 1. What is the primary purpose of a load balancer in a backend architecture? A load balancer spreads traffic across many instances, so none gets overwhelmed, and it's what lets you scale horizontally behind one stable endpoint. Health checks pull dead nodes out automatically. It's also where you terminate TLS and do Layer 4 or Layer 7 routing. In short, it turns many servers into one reliable address. Question 2. How does a database connection pool manage connections when traffic suddenly spikes? A pool keeps a small set of reusable connections instead of opening one per request. On a spike, extra requests wait in a short queue instead of flooding the database. That's back pressure. The key rule: cap the pool at or below the database's connection limit, because unbounded connections are what take it down. For many app instances, put a proxy like Page Bouncer in front. Question 3. When would you choose a message queue over direct API calls between services, and why? Reach for a queue when the work can be asynchronous and you want to decouple services. The producer shouldn't block on the consumer. A queue absorbs spikes, applies back pressure and retries failed work without losing it, and it lets many consumers react to one event. Use a direct call when you need an immediate answer. The trade-off is eventual consistency. Question 4. What happens internally when a container is OOMKilled? And what are your first 3 diagnostic steps? OOMKilled means the kernel killed your process for exceeding its memory limit. A hard kill. Exit code 137, no cleanup. First, describe the pod to confirm it and check the restart count. Second, compare the memory limit against actual usage. Is the limit too low or usage too high? Third, find the cause. A recent deploy, a leak you catch with heap profiling, or an under-provisioned limit. Question 5. How would you design a caching layer for a high-traffic product catalog to prevent cache stampedes? Put cache aside, Redis in front of the catalog. A stampede happens when a hotkey expires, and 1,000 requests rebuild it at once. Stop that with single flight locking, so only one request rebuilds the key and the rest wait. Jitter your TTLs so keys don't expire together. and refresh hotkeys in the background before they expire. Serve stale while you revalidate. Quick pause. These questions come from Quest2Offers. AI mock interview. Technical or FAANG format. The AI asks questions for your exact role. You answer in writing, and you get a breakdown of your weak spots. Try it free at Quest2Offer. Then back to the questions. Question 6. In microservices, how do you handle distributed transactions? Without two-phase commit, use the Saga pattern, break the transaction into local steps, each with a compensating action that undoes it if a later step fails. Coordinate with events for simple flows or an orchestrator for complex ones. Publish those events reliably with a transactional outbox and make every handler idempotent. You're trading a global lock for eventual consistency. Design the experience around it. Question 7. How would you implement rate limiting at the API gateway, and what algorithm would you choose? Enforce it at the gateway before traffic reaches your services, keyed by API key or user. Token bucket is the standard. It allows short bursts up to the bucket size while capping the steady rate. Keep the counters in Redis so the limit holds across every gateway node, not per instance. Return 429 with retry after, and switch to a sliding window if you need smoother limits without bursts. Question 8. How does Raft keep data durable when a majority of nodes fail? Raft commits an entry only after a majority of nodes have written it to disk, so any committed write survives losing a minority. If a true majority goes down at once, Raft stops accepting writes, no quorum, and deliberately sacrifices availability to protect consistency. When nodes recover, an election picks the most up-to-date log as leader, and it replays committed entries, so nothing acknowledged is lost. Question 9. How would you shard a user table that grows to billions of rows while minimizing cross-shard queries? Shard by a key that matches how you read the data, usually a hash of user ID for an even spread. Then a user's rows all live on one shard, so the common queries hit a single shard. Use consistent hashing or virtual buckets so you don't get hot shards and resharding stays cheap, and co-locate related data under the same key. Or denormalize so you almost never need a cross-shard join. Question 10. An endpoint suddenly returns 503 seconds, but CPU and memory are normal. What do you inspect? First, 53s with normal CPU and memory tell you. It isn't compute, it's downstream or saturation. Check your connection and thread pools and the request queue depth. Requests are waiting, not working. Look at dependencies, a database, cache, or upstream timing out, or rate limiting you into 503s. Correlate with the last deploy and your load balancer. Health checks. Then trace one failing request end to end. That's all 10. If this helped, like and subscribe and try a real mock interview at Quest2Offer. Good luck on your next call.